This is an example of a confidence interval for the difference of two population proportions. A Harris poll asked Americans if they agreed with this statement: artificial intelligence has widened the gap between rich and poor in the United States. Of those aged 18 to 35, 69% agreed with the statement. Of those aged 36 to 50, 60% agreed with the statement. Suppose there were 120 people surveyed in each age group. Construct the 95% confidence interval for the difference in the population proportions. Explain what your confidence interval tells you about the difference between the population proportions. So in this problem, when there's so much data given to us in sentences, I often think it's helpful to make the data into a table. So there's two groups that we're considering: those who are aged 36 to 50 and those who are aged 18 to 35. Now for both of them, the sample size was 120. For the younger group, 69% agreed with the statement. So we have to find out how many people that was. So we would need to find 69% of 120 people. And if we do that, we get a value of 82.8, which we need to round up to a whole number, 83. So roughly 83 people out of the 120 agreed with the statement. Now in the other age group, only 60% agreed with the statement. And again, let's find out how many people that would be. So if we take 60% of 120 people, that comes out to 72. So 72 people in the other group said they agreed with this statement. Now, you might say to yourself, well, we already know there's a difference in the percentages. One percentage was 69%, the other percentage was 60%, so obviously there's a 9% difference. Remember, these are sample proportions. So we already know that the sample's proportions differ. But what we're trying to figure out is if the population proportions differ, meaning if you asked all people in age group 18 to 35 and all people in age group 36 to 50, would we find that there's a difference? Now, obviously, we can't ask everyone. So the question is, can we, just using this sample data, figure out if there's a difference between the two population proportions? And the answer is yes, given that we can apply the central limit theorem. Now remember, in the central limit theorem, we take n times p and n times 1 minus p, and we want to see if that's greater than 10. Now, p is a population proportion, but in this case, we don't have a population proportion. We have two sample proportions. And so what we do is we take the information in the problem and we pool it together to come up with a number that we're going to use to see if we can use the central limit theorem. So I'll show you how that's done. So what we're going to do is we're going to take the total number who said they agreed, which is 83 plus 72, over the total number of people was asked, which was 120 plus 120. And this is called the pooled sample proportion. So let's take a look and see what we would get if we computed this. So 83 plus 72 gives us a total of 155. Out of 120 plus 120, that gives us a value of 240. So if we take 155 and divide it by 240, we get a pooled proportion of 0.646. And so we would just need to show that 0.646 times 120 and 1 minus 0.646, which would be 0.354, times 120, that these are both greater than or equal to 10. And the answer is yes, they are. And that simply means that we can go ahead and use the central limit theorem. So what we're going to do is we're going to take the information in this table, 83 out of 120 for one group, and 72 out of 120 for the second group, and we're going to use technology to give us a confidence interval for the difference in the population proportions. Now, the easiest way to do this is by using StatCrunch. So let's go to StatCrunch and talk about how we would do that. So we come here to Stat, and we're working with proportions. We have two groups, and we would like to do a problem where we have a summary of the data. So in the first group, aged 18 to 35, the younger group, we had 83 people out of 120 who agreed with the statement. And in the second group, the older group, we had 72 out of 120 people agree with the statement. And we're going to find a confidence interval. All right, and we'll come here to compute. So our confidence interval has a lower limit of negative 0.029 and an upper limit of 0.212. So let's go ahead and record that and talk about what it means. So in this problem, when we put our data into our technology, we got a confidence interval of negative 0.029 and an upper limit of 0.212. And the first thing we should notice is that this confidence interval has a negative number on the left and a positive number on the right. And just think about a number line. Negative numbers are numbers which are less than 0. Positive numbers are numbers which are greater than 0. So if you have a confidence interval that has a lower limit that's negative and an upper limit that's positive, you can be certain that 0 is inside the interval. And remember, we're making an interval for the answers that we would get if we subtracted the first population proportion from the second population proportion. So what we're told is that it's possible that we could get 0 for an answer. And the only way you can get 0 for an answer when subtracting is if the numbers are the same. So what this tells us is that there's no significant difference in the population proportions. There was a 9% difference in the sample proportions, but that was not strong enough evidence to tell us that the population proportions would be different. So our conclusion would be there's no significant difference in the population proportions.